So this talk is about Cedar. It's an open source project that we launched last year. So I work for AWS, and I focus on open source. I've been working with open source for over 20 years, and one of the things that I love about open source is that developers come together, they have a problem they want to fix, they write code, they get a community around it, and they make that project go forward. And so this is a project that addresses a problem that a lot of developers have, which is around how do you authorize access to your application resources. And it sounds like a very simple thing. Now, I've been working in technology for over 35 years, and even though we've done, we've had cryptography before, we've got authentication, authorization is still one of those problems that is still not really kind of cracked, until maybe now. So hopefully you're all going to learn about this project, and you'll see how you can potentially use this to solve some of your authorization problems. But first of all, I want to start off with actually what is authorization. And quite simply put, it's how we as developers can make sure that we guarantee that only those people, those principals, have access to the resources within the applications that they are allowed to have. Okay, and that's what we mean. So in any multi-user application we create, we're going to have users. Those users are going to need to access different resources. How can we make sure that only those resources are accessed by the people who are allowed? Now, over the last 20 to 30 years, a lot of work has been done to solve this problem, and a number of different approaches have been created. RBAC, which is role-based access control, which is typically a hierarchical approach. So you can think of it as a directory tree. So, for example, I'm in an organization, I'm in a department, and I give access to anyone in that department. And that approach, for people who are familiar with directories, is a good approach. However, when you want to use that to provide authorization at a very fine-grain level, you end up needing to create lots of groups. And you end up in a situation where you have tens or even hundreds of thousands of groups that control access to your resources. And I know I've done plenty of data center migrations, application migrations, where the biggest problem we've had was, how do we know who's got access to our applications? ABAC, attribute-based access control, is where we define attributes of resources, typically used by social applications, and we govern access to those. And these are very nice, they're very easy to use from a fine-grained perspective. But the problem is they're very opaque, and what that means is that it's very hard to know who has got access to what. And then relation-based access control, which is a more new one, which is kind of combining the two. So we've known about these approaches, and many applications use one of these to do authorization. But even though these are well-known and well-understood projects, there are significant problems. The first one is if you've got a monolith application written in one language, for example, Java, and if you're using Spring Security, you can easily provide authorization within the application because Spring Security is a very well-known framework. But these days, in decentralized, heterogeneous applications that are written in not one language, many different languages, how do you make sure that you provide authorization to an application that's part Python, part Go, part Java, part something else? You need something that works across all of those. That's kind of the first thing. The second thing is that when you think about authorization and how we traditionally have done it, it's required someone going into the code or doing a deployment. And that makes it very hard to maintain. It makes it very hard to analyze. And especially if you're doing an audit, for example, if you're in a regulated industry, how do you make sure that you separate your application logic from your authorization logic and make it so that only those people that need to access it or change it have got access to that? And so these are kind of the problems. And over the years, developers have implemented this logic into their code. Now, this is not a real code, but I think anyone who's done authorization logic will understand this, okay? Now, I'll put my hand up that this is something I do. I'm not proud of it, but it's what we work with, right? But what if we could improve this? What if we could define and extract our authorization into a policy and then call one function that uses that policy and do that consistently, whether it's in Python, Rust, Go, or something else. And that's kind of like what Cedar it does. But before I get to that, the temptation as developers is to build your own. Now, who here is going to be brave and put their hand up and saying they've developed their own authorization system? Yeah, exactly. You are my people. I've done it many times. And it's hard, right? It's hard for lots of different reasons. The first one actually is that the actual mathematics involved in creating your model for access is really complex. It involves lots of complex mathematics. And, are you the best person to develop that? Who knows? The second one is, how do you actually trust that the authorization logic you've created works? I joke with other people who've created them. I said, would you bet your house, would you bet your life on the authorization logic that you create? I know I wouldn't. Okay, so how can you make sure that the authorization engine you use, you can trust? And then the final one is that there's no point having any authorization system if it can't operate at the speed of your application and your customers. Yeah, so whatever you build, it's got to be performant. And so these are kind of the three attributes that make building your own authorization system really hard. And so this is what Cedar has tried to do. Okay, it's effectively an open source project that has a number of components. The first one being a domain-specific language around creating policies that allow you to access or deny principals from resources. The next is actually an engine that you can put requests through, and it will provide either yes, this person is allowed to access that resource, or no, this person is not allowed to access it. But it does it in a really interesting way, which I'm going to come to in a minute. And then the third one is it provides tools to make all the policies that you create easy to understand, easy to read, and also easy to analyze, which is really important when you're looking at from a kind of audit perspective. So I'm going to break these three things down before I jump into some code. So who's familiar with policy-based authorizations? Yeah, a few. Okay. So is that through something like Riga or Rigo or OPA? Yeah, that kind of thing, yeah. All right. So effectively what a policy-based authorization is you write a policy that contains a number of things, and then your application will make a call to using that policy to know whether it's allowed to access that resource or not. And within Cedar, the way that we create these policies, and I'll actually show some specific examples when we go into the code, is that they have three things. The first is an effect, and within Cedar, there's only two effects. You either permit or you forbid. Simple as that. There's no maybes, right? The second is the scope. And this is how you start to narrow down what application resources you want to permit or deny your access to. And then the final is the kind of condition, which is more kind of attribute-based, where you can start to add fine-grained information, such as, for example, maybe the IP address you have, or maybe some headers that your MFA token will provide, or maybe anything that your application requires. So you can use these three things to create policies. And this is what they look like. So we have the effect at the top, permit. We have the scope. So we have principal, action, and resource. So the principal is the group of users. And we'll come to it in a minute how it knows what they are in a second. Then the action. And the action is what within your application is this specific request or policy covering. And then finally, the resources, application resources. And then the ABAC stuff is at the bottom. We call it the condition, is where we can actually either specify some additional constraints we want to govern. So this is an example of a policy that you might create for an application. Now, one of the things that we deliberately set out to do when we created Cedar was we wanted to make sure that it was readable, human readable, because that was one of the design goals. When we often asked why both first of all, why we created Cedar in the first place, and secondly, why policies look like this. We created Cedar because when we looked at some of the other projects, open source projects out there, the kind of policies were very complex and difficult to read. And our customers, when we were betaing this project, customers said they wanted simple policies like this we could break out, and so they kind of governed the direction of our policies. Now, in that example, you might be thinking, well, how does Cedar know when I'm writing a policy? How does it know? In the specific example here, I've got action, delete photo, resource, application, photo app. How do I know that? So one of the things that when you're creating and using Cedar is you have to define your application. So you model your application resources, and you then use that definition within the policies you write. So in the bottom here is, and I'll show you this in the code in a minute. You define what your application looks like. Now, in my example, I've got a flat file, but you typically might get that from a database or something else. And then you can pull those into your policies you create. So in my example, I've got a photo application. And so some of the actions and some of the attributes around view photo, album, user, photo, that kind of thing, are things I would define in my schema, and I can then refer to those schemas in my policy. So the effect I mentioned already is only two. And the scope, which is how you reduce the breadth of your authorization, allows you to effectively combine those three, the principal, action, and resource, which I've covered already. Now, when you're actually, in the examples I'm going to be showing you, I use very simple names like user John or user Rick or application photo album. But when you're using this in reality, you wouldn't do that, okay? You would use a unique reference, so something like a UID, and that's what your policies would actually look like. Okay, and the reason for that is that if I'm a user John Smith today and I change my name to John Sueiras tomorrow, I don't want to tie that into the authorization logic. Okay, and also it's not scalable as well. So the conditional clauses allow only two things: when and unless, and so these are very, very useful. For example, because you can forbid access to all resources unless you've got MFA enabled, that kind of thing. So it allows you to kind of put some more granularity on how you define your policies. When you're defining your policies, the actions you define within your schema, you can group together, so you don't have to have lots of different policies to do one thing. And you can, from a multi-tenancy perspective, you can group policies and you can group attributes within the policies into namespaces, which allows you to then define, and how to do that across different applications. So that's a very kind of quick overview of policies. It will make more sense when I go into the demo and I actually show this. So once you've got your policy, okay, how do you actually use that? So we have three inputs to authorization decisions. We have the policy, which defines how you want to provide access or authorization to your application resources. We have the actual application schema, so the stuff that actually your application defines your application. And then we have the context, so the session of the user. These are all input into the authorization engine, and you get one of three outputs. So I know it's only two there, but there's three outputs. One is allow, one is deny, and the third is an error message. So if you get it wrong, there's an error message, which hopefully will help you solve why it got the error. Now, how Cedar evaluates permissions is very simple. If there's nothing there, you will not get access to anything. If you are explicitly mentioned in a policy, you will be allowed access. But if there's a conflict between allow and deny, you will always get deny. And so that's a very simple model on how Cedar evaluates. And again, it's one of the things that makes Cedar slightly different to some of the alternatives out there. But at this point, and what I mentioned earlier, how can you trust Cedar, right, as an authorization engine? If you create policies, how am I willing to bet my house or even my life on something like this when I've never been able to do that before? And the answer is actually how we built Cedar in the first place. We have a research team within Amazon that does a lot of work on formal reasoning and formal methods. And we use a number of different tools. But one of the tools we used specifically when building Cedar was a tool called, first of all, Daphne and now Lean. And what these allow you to do is from a specification. So you define a specification. And I link to the actual paper that has the mathematics for the spec. And then you write using the language, so in this instance, Lean, you write a version of Cedar in that language. Now, it's good because it provides formal reasoning tools that allow you to prove correctness. And what that means is mathematically, we can guarantee that an authorization result is valid and sound and secure. But the problem with we can't release that as a tool because it's not performant. And one of the attributes of an authorization system is it has to be performant. So what we do is we build an alternative to that in Rust, which is memory safe, it's performant. And then what we do is we build a thing called differential testing, which allows us to take hundreds of millions of inputs, so different policies, different contexts, different from a sample application. And we feed it into the Lean version, which we've got the tools we know is correct. We feed it into the Rust or our own version of that code, which doesn't have those tools. And if we have no bugs, the result should be the same. So we should have an allow access or deny access. But sometimes when we were doing this test, we were finding that the code from the output authorization decision from Lean would be allow, and it would be deny in the Rust version. So we know we found a bug. And so we fix the code, we run the test again until, these are run like hundreds of millions of time until we have no deltas, okay? And then we have a release that we can publish. And this is a really interesting way of so yeah, this is the kind of the thing that happens after we've created that. Now there is actually a blog post that details in much more detail that I'm going to cover here how this works. But the takeaway is that the authorization engine has been created in such a way that we can prove correctness and prove security, which means when we have a policy and we submit it to the authorization engine, we know if it's an allow access or deny access, we don't have to worry about whether it's our code or it's something else that's wrong with it. And then the final piece, okay, is the analysis, right? And it's interesting because you might not obviously think about analysis of your authorization logic from the beginning. But when you're running at scale, if you've got an application that's got hundreds of thousands of users with many, many different objects you're trying to access, and you want to migrate, for example, users from one version of the application to the other, having tools that allow you to either consolidate policies or even check, for example, whether users have got too much access is really, really important. So this is kind of like equivalence and assumption. So assumption is where you have too much access. You might have different policies and you might move from one group to another, but you've been left out of that group, so you've got too much access. So these are capabilities that Cedar provide that allow you to manage your policies going forward. So anyway, I've talked a lot. I want to actually show you this stuff now. So I've got a very simple demo app. It's a photo app. And we have a number of actors. So we have John Doe and Jane Doe, who are part of the family The Does. I don't know why I use that name. I should have checked something, but anyway. And they own a number of photo albums. So it's a photo sharing app. And we have admin who runs the site. We have me, that is a site admin, and then we have Joe Public, who is anyone, right? And this is typically, kind of an authorization model you might want to model, right? You might have, for example, rules around, members of the public group, or maybe just authenticated users can access an album. Only members of the Doe family can access private photos or manage photos, that kind of thing. So let's actually come out of this. I'm going to sit down now and do this. And hopefully the demo gods will be kind. And I've got the code is all available on a repo, which I'm going to share at the end on a QR code. So I'm just going to run the application and hope this works. And it's all running on my local laptop. Everything is local. So first of all, let's look at the actual application schema. So what I talked about. So in this instance, I have a photo app. I've defined some specific entities. For example, this is context. So the context that I might submit to a session. Here I've got IP address, authenticated Boolean or MFA. Then I've got typical attributes you might have in an application, a user who might be a member of a user group, a photo that might be part of an album, and an album that might be part of other albums as well. Okay, and then typically the things you might want to do in your application. So a view photo, manage photo, and site admin, right? So it's a very, very simple application, deliberately done so it makes it easier to understand how these kind of moving parts work. Then within my application, I've got some entities. So this is the kind of the stuff that within your application, your users, your groups, which I'm modeling here as a file. But typically, if you were using this in your own applications, you would be probably storing this in a database and managing it in memory. And then we've got my policy, my Cedar policies. Okay. Now, at the moment, these are all grayed out. Okay. So because I've got no policies here, any request to my application should do what? Deny. Okay, well, we'll see if that works, right? Hopefully. And this is a Flask application because I like Flask because it's a nice application that makes it simple to kind of get across some of these ideas. So in this application, I am just using standard Flask to authenticate users from a flat file. So I've got a number of different users here. Don't do this, okay? Don't do this. And then I want to show you the authorization logic because I have within the application, within the different routes, the admin route, the photo route, you can see that my authorization logic is this. Okay, I make a call to the Cedar authorization engine. I submit to that the Cedar policy, the request, so as in like the HTTP request, the schema, and the entities. The false is just verbosity, true or no. So that's not part of it. Not interesting. And then so from that, I will either get two decisions: decision deny or decision accept. And so the logic here basically says that if I'm denying to display the error denied HTML page. And you can see that the logic is the same for every single one. So now my logic really, my authorization logic has disappeared from having that nested group of, you know, ifs and elses into just one common line. So let's now try and see if this works. So let's make sure it works. So I'm going to log in first of all as admin, who should have full access. So I'm logged in as admin, but if I go to all the application resources, you can see that I don't have any access at all. And we can try that again with Joe Public, just to show you it's not off. So again, so let's start now building some policies, okay? So the first policy, which I'm going to do, so this policy basically says principal, and there's nothing after principal. When you have just the name principal, it means that all principals within the application. I've got a specific action, which is view photo, and a specific resource, which is the public photos. But I've also specified an additional attribute, which is that I'm only going to allow users to access this if they've been authenticated. So if I now try and access, yay! So these are photos actually I took yesterday when I was walking around Italy. But if I try and access the other resources, you can see that. But let's actually change the application now. So if I go to so at the moment, the context for this user is where I've got public photos. I've got authenticated equals true. So let's change that to false. So now I'm not authenticated. Oh, okay. I know why I had to do that. hopefully this will fix that. Okay, let's try that again. Demo gods be kind to me. You can see now that I can't access it because I've specified in the context this user is not authenticated. So, and that's something that I find strange with this Flask application. Sometimes I can do a hot reload, and sometimes it doesn't. So I don't know why that is the case. Right. Okay. So that's the first one. Let's now try something else. Let's try and see how we can allow part of the Doe family to access their photos. So here we've got a number of different policies. This one allows anyone in the Doe family to view photos in their album. So let's save that. Let's log in. Actually, let's do that. So now we should be able to see that and my photos. All right. So I did a pasta cooking class yesterday. Highly recommend it. If you're in Italy and if you're in Florence, you've got to learn to cook properly Italian. But if I try and manage photos, I'm not allowed to do this. I can look at my own photos. I can look at public photos, but Jane can't. And if we look at the policy, we can see that the reason for that is that only the view photo, not manage photo attribute. So if I change this to this one, which has the manage photo, now hopefully my photos, manage photos, I can now manage photos. So you can kind of see how this works, right? As an architect, as an application owner, I don't have to go into the code now. I've not changed the code. I mean, in this example, I'm spoofing the sessions, right? So you wouldn't do this in your real applications. But all I'm doing is just changing the policies within here, and that's then governing access control. And this policy is not language specific, right? So I'm using Python here, but it's the same policy that would be for Java, for Rust, for Go. So it allows you to do all things. Now, one other thing that I'm going to show you as well is that let's do this. Now, maybe what I want to do, I've got a forbid rule here. Now, the forbid rule, okay, here says that I allow anyone to access and manage photos only if they're the owner, right? So I've got two Does, two parts of the Doe family. So if I log out and log in as John Doe, so even though this person has got access to the policies, and look, he can't look at my photos or manage photos or admin. And the reason is because he's not the owner of the photos. If I remove this policy, then, why is that then? I think it's another one where I've got a Control-C and it. Let's log out, log in. Nope, why is that then? Doe photos, it's manage photos. Where is it? Oh, okay, that's because this one, okay, let's do that one as well. And now, that's it, my photos. Oh, okay. See, this is why you don't do demos live. So I'm not sure why it's not doing that. It should allow me to do that. View photo, hang on, that's because of this. No, that's because of this one. So once you start, okay, now, there you go, now works. So I think I've just got too many policies here, so it gets a bit confusing which one I need to use. But I think what I've showed you here is how you can actually very, very simply use Cedar to provide authorization against this application. So let's go back to the presentation. So what's happening in this application, okay, is as a user comes into the application and as they access a resource, the resource, which is on the right-hand side, provides or inputs, the inputs effectively are the policies, the entities, and the schema from application. That then gets basically put to the Cedar library. Now, the Cedar library is actually using a project called OY3, which basically is how it integrates. So the actual Cedar engine itself is Rust. So I have Rust running on here, and Python is using the binding, the OY3 project, to effectively natively talk to Rust from Python. We don't have a native Python version of Cedar. So, in fact, in all the other languages, so Java, Go, they all still use the Rust underlying authorization engine because that's the one we know is provably correct. We haven't done the same work for other languages. Now, a couple of months ago, there was a research paper published by the team that created Cedar that looked at how Cedar compares with a couple of the other open source authorization frameworks. So OpenFJ and there's a few actually. I read the paper a couple of weeks ago. Even though the graph only shows a couple of them, there's actually about 11 of them that are reviewed. Now, what's interesting about this is the performance characteristics of Cedar. Even when you're running at huge scale, so when you've got hundreds of millions of authorization requests and objects, the scale or the performance characteristics of Cedar do not change. They're still flat. Whereas what we see with some of the other open source authorization engines, they start to increase latency in their authorization decisions. So when we look at the characteristics of what we want from an authorization system, we want it to be performant, we want it to be correct and secure, and we want to make sure that we can easily understand the policies and reason on them. These are kind of the three ticks and why we created Cedar. In fact, actually, there's a little data point in the actual. I didn't see this until I read the research paper. The performance improvements over some of the other projects is quite impressive, actually, from an authorization decision. Now, I showed you the library, but there's also a CLI, and the CLI allows you to do the same sort of thing, right? Take a policy and test it for various scenarios. What this allows you to do is it allows you to now start building authorization into your automatic application deployment processes. So you can build tests, create your policies, run them through your CI/CD system, and make sure that what you're expecting is what you're getting. So for the first time, these tools are allowing you to now build authorization as part of a continuous deployment plan, which is pretty amazing, actually. Now, I've showed you everything on the open source side, right? One of the questions I always get is how do you manage the entities, how do you manage the schemas, and how do you manage the policies for your application? So that's down to you as a developer, right? That's the beauty of open source. It gives you that flexibility. But sometimes you don't want that flexibility. You want someone else to do it, right? So there's a managed service for this, which we created, Amazon Verified Permissions. So if you like what you see and you try it out, but you're just sick and tired of managing all those, take a look at this. There are also a couple of other managed authorization providers that are using Cedar. So Permit.io and StrongDM are using it as well. So you've got choice, right? There's a number of alternatives you can use while still using Cedar. So if you are interested in learning more about it, there's a couple of resources I'm going to share with you. First is the actual repo. There's also an online place. I'll show you what that looks like. If I can find it. So it's called a policy playground, where you can actually, without having to install anything, you can actually play around with sample policies, sample entities. There's a couple of examples, a healthcare app and a photo sharing app. On the GitHub repo, there's also a GitHub version as well. And it's a really kind of cool way of learning how to kind of work with the Cedar policies. And finally, it is an open source project. It's in active development, so the community is driving forward the direction of this, including a number of RFCs. If you're interested, you can help drive the direction of it. If you want to get more hands-on, there's also a workshop you can do, which is pretty cool. And that is actually the end of my talk. If you want a copy of the presentation with all the resources, and the first 20 people will get also $25 AWS credit voucher. Not that should encourage anyone else or more to do it, because you don't need that to run this. So thank you very much. If there's any questions, I'll happily take them. Otherwise, thank you for your time. And these are my social credentials. You can always contact me to ask anything about Cedar that way.
Okay, so we have some questions from Slido. The first one says, can you elaborate more about how you compared the test results between Lean and Rust?
Yeah, so the way it works, the differential testing approach, it requires you to basically have the assumption that one version is provably correct. Okay, so in order to do that, you have to use one of the tools or languages that allows you to do that. So there are a number of, there's TLA+, there's Daphne, which we used previously, and the one we're using now, which is Lean. And what this tool does, you define a specification of your authorization, what you want it to do. And that allows you to build working software. What this means is that you can create a policy. And this is all on. It's all on the repo, so you can reproduce this yourself. So the repo has a number of different tests, different policies, and then you run those. Because you literally submit the request of the policy, sample entity, sample schema into the authorization engine. Lean provides tools that allow you to prove correctness. So it's basically mathematics, and the output. So you can say, is this a valid correct? Is this request valid or correct? We can't do that with tools like Rust. They don't have those mechanisms. So all we can do is we can measure the output of the authorization request. So as in like from the CLI, I can run Cedar verify or Cedar authorization with the same inputs, and I'll still get either allowed or denied. So I've got a way of comparing the stuff from Lean, which I know is always the truth, and I can now compare it to anything else. So we could have done it in Python or something else, but we use Rust because of the characteristics of Rust being performant, memory safe, and all that kind of stuff. And so when you do that with one policy and one example application, you get one result. But that's not good enough, right? You have to do it for loads and loads of different ones. So the differential testing, which is what is outlined in the blog post, talks more about actually how we did that, how we randomized the data, input data. So you get all sorts of inputs and outputs, but we know for each of those what the output should be based on the tools that Lean provides. So we know the top one, we just don't know the bottom one, and that's why we run that test over and over again. And in theory, if the code is good, then they should have the same output. And during the testing and development phase, that didn't always happen, right? So that meant we had code bugs in our Rust implementation. So, but the blog post it actually has some of the mathematical kind of proofs that we used, and also goes into some of the details. So we started off with Daphne initially, but we moved to Lean, and the reason why we moved to Lean was because some of the proofs are actually provided by the open source community of Lean. So before we were providing all our proofs ourselves, and we found that as we moved into this area, it was more beneficial to use some of the open sourced proofs out there and contribute to more from our team. So that's the reason why we moved from Daphne to Lean. But it's still the same principles. So I'm not sure if that answers the question, but it's at one level it sounds like very simple, but when you go into the details, it requires a lot of complex mathematics, and that's way above my head.
Okay, thanks. The next question read, how do you keep your app and policy code in sync and deal without backwards compatibility? Is the schema used for code gen to create symbols to import using code?
Yeah, so that's a very good question, because I only got my demo working about half an hour ago, and it was only working because my schema was not in sync with my policy, which was not in sync with my application. So there's a couple of ways of looking at that. First of all, the Cedar provides tools for you to check, to validate your schema, your entities. So before even I commit my policies, I can use the tools within Cedar to validate. So in the CI/CD example, that's how we are using it, right? We don't want to commit policies that are going to break. So we need a validate function, and so we can validate our policies and validate our entities. If they are validated, that doesn't necessarily mean it gives us the same the result we want, authorization allowed or denied. So there's kind of those are two. That's a second step, right? So, but to make sure that your application entities, your Cedar, your schema, and your policies are good before you publish, there are tools that are provided to validate that.
Okay, thanks. So we have another question. Can you do auth in a middleware based on decorators on the controller? How to handle fetching resource data in that case, e.g. rest delete ID, check property X?
If I understood that correctly, how would you bring in additional application context into the request? Is that who asked that question? So,
yeah, I had the available space, so I included it. But that's what I meant. Basically, you have a middleware, you need extra context.
Yeah. Yeah, so this is actually, I get this, so I always get this question, right? And this is one of the compromises we had to make when we developed Cedar, right? So it's not as expressive as some of the other languages. So we only have a limited number of, for example, operations that you can do in the context. And that's unlikely to change. And the reason for that is, well, two reasons. First of all, it's difficult to formally prove something when you do that, right? And secondly, it actually impacts performance. So some of the other languages, open source authorization languages, they do those, right? So they have loops, for example, and ifs and all that kind of stuff. And the problem is we can see that as you get more policies and more entities, the performance just drops, right? Whereas ours stays flat. And so that is a compromise we've had to make. But if you go to the open source project, it's quite interesting. A lot of people want them back, right? They really, really want them. And there's this this tension between people wanting that functionality, but then the kind of the controls being that it's got to be performant, it's got to be provable, right? It's got to be correct. So whether that changes, I don't know. But it's definitely a compromise we've had to be happy with. And to be honest, most of our customers are okay with that.
Okay, so the last question. Is it possible to describe a multi-tenant application in Cedar with the user being a part of one or even multiple organizations?
That's a good question that I can't answer. So I'm going to have to think about that one. So multi-tenancy does come up. There are a number of ways that Cedar supports multi-tenancy, mainly in this concept of policy template. So you can create a policy template, say each of your tenants have it. Currently, only two of the attributes in the scope, so principal and resource, you can actually define. So in theory, if it's just a user and a resource, you could potentially use those, so policy templates to do that. But I've not done it, so I don't want to commit to that because I've not tried it. But yeah, I mean, it's an example. It is something I get asked a lot. One thing I would say is that for multi-tenant applications, most people tend to go straight to the AVP managed service because it handles all that for you, right? So whereas I'm focusing more on the actual open source stuff here to get people interested in it and seeing if they use it. So I think once you get to multi-tenancy, you have to do a lot more engineering to kind of to get that working because we spent a lot of engineering work trying to get the AVP stuff running. So yeah, I don't have a good answer to that, unfortunately.
Okay, we have time for another quick question.
Hello, so Roman here. I've been past several audits in my life where I was staying in front of the people on the carpet and answering to weird questions. And the questions are usually, why at this point of time, or at that point of time, this particular dude was able to do that particular action. So is there any plans to implement something like audit log and give the explanation of decision, either it's allow or deny? So
there is. So I didn't show it in the demo, but the native Rust library does have verbosity. So what it will do is it will actually show you either for every forbid and deny request which policy was activated. Right, so in the code, so here you can see that the first line is // policy number. Oh, yes, sorry. you can see here, there's / policy 0, policy 0A, and what the tool will do, when you put it in verbose mode, it will actually say that this is the policy that invoked it. So that's how you know. Now, if you log that to your own applications, then that's how you would know for everyone. So I didn't do it for this example, but yeah, it's a good question. Yeah.
Okay. Thanks to Ricardo.
Thank you.